Oh, okay. So we are doing operations with our higher index radicals. So, does anybody have a preference which we do first? Add, subtract, multiply, divide? Well, add, subtract kind of go together.
What one's the hardest?
I would say dividing.
Let's do dividing.
You want to do that first?
Get out of the way. Multiply.
Let's start with multiply and then we'll divide, okay?
Wait, is dividing harder?
A little bit.
Oh, then can we do dividing first?
That's what I'm saying, you know?
You get the hard stuff faster.
I don't know.
Even faster.
Even faster.
Yeah. Oh,
Well-
we're screwed. We're done.
All right, guys. So here's the thing with multiplying. As long as, are you listening? As long as you are multiplying two numbers that are under the same radical, you can multiply them together. So see how these are both cube roots? If one was a square root and one was a cube root, I really couldn't do anything with them. But if they are the same, then I can just multiply them together and keep it under that same radical. However, you need to make sure that your answer is fully simplified. So now, since these are perfect cubes, I would look at my perfect cube list and make sure that none of these numbers in my perfect cube list, besides 1, divide into 24. 8 does, so I'm going to have to simplify this answer. So you can't leave your answer like that. You're going to have to fix it if you need to. So split it up into the cube root of 8 times the cube root of 3. So my final answer is actually 2 times the cube root of 3. All right, so if we just look at number 6 really quickly, you'll notice that in number 6, I do have different roots here. So you have to be careful.
You can just move that around so you can multiply like the cube root with the
Right, these two that are both cube roots can absolutely be multiplied. I have to multiply them together because they're both under the cube root sign. So I would get the cube root of 8, and then what happens with this guy, the fourth root of 3? It just stays there, times the fourth root of 3. Now, is that a good final answer?
No.
No, of course not.
Simplify the two.
Even easier than that. Oh wait, 2 times the fourth root of 3 is your final answer. Yes, correct. So the third root of 8, Phil is saying, hey, that's just 2, so you just turn that into 2 times the fourth root of 3. And that is your final answer. So just make sure if you have multiple different roots, only the roots that are the same can be multiplied together.
What do you mean how's that the final answer?
Where would you go?
Okay. I forgot that 8 is a perfect cube.
Right. So 8 is a perfect cube whose answer is 2. Okay, so there is my final answer there. So before we move on, just jump up to 2 and you guys try 2 without me telling you what to do.
Cheese and crackers.
What one did you say?
2. Okay, we got an answer? Yeah, sounds good to me. So if I take a look, they're both under the cube root, so I can multiply them together, and 5 times 25 is 125. But then I look to see if I can simplify that answer. Well, lo and behold, 125 is a perfect cube whose answer is just, it's just 5. The cube root of 125 is just 5, so it just simplifies out to be like that. Okay, so the only way that multiplying with radicals gets any harder, maybe if we have some variables out in front, bless you. So I'm just going to make one up real quick. Say I had like, I don't know, -4 times, let's do the 4th root of 5. And I want to multiply that by, I don't know, 3 times the 4th root of, trying to pick a nice number here. 125. So this is all multiplication, right? So another way, you could rewrite this as -4 times the 4th root of 5 times 3 times the 4th root of 125, right? It's just multiplication. So what are you going to do? Yeah, the -4 and 3 you could certainly multiply together, so that gets me a -12. And these are both under the 4th root. So 5 times 125 is 625. And then I just ask myself, okay, can that be simplified? Well, I look at my perfect fourths, which are here in purple. Perfect fourths. Oh, looky-loo. 625 is a perfect fourth. So the 4th root of 625 is just 5. So this is really -12, and then what's the operation between these two? Times. So it's a -12 times 5. So that answer is just -60 at the end. All right, so that's it with multiplying radicals. Just make sure that it's like radicals get multiplied with each other. And then you simplify your answer if you can. Sometimes you can't simplify your answer and you're done. All right, any questions on multiplying? All right, let's talk about dividing then. So same thing goes with dividing. You can only divide with each other ones that are in the same radical, okay? So these are both under a cube root. So when they're both under a cube root, same thing when they were both under a square root. I don't know if you remember, but for a fraction, you can actually rewrite it as the cube root of the fraction, just like that. You can split them up, or you can make it one big one. You can go forward or backwards if you wanted to. But what's 6/3 really? Just 2, so this whole thing really just simplifies to be the cube root of 2. Remember, you're not allowed to leave radicals in the denominator. So luckily I don't have one in the denominator. If I did, that's another story. My plan was to do it on Monday, but if you really want to, I guess we can.
Monday sounds fine.
Well, we'll see. Maybe one will come up. I'm not sure if any of these make it happen or not. You guys try 9. So hopefully you notice, okay, these have the same radical. So basically, it's like I can treat it as one big fraction. I can reduce these with each other if I wanted. So 15/3, yeah, that reduces. So in other words, it's like doing the same thing. 3/2 times a big old cube root of 15/3. Well, 15/3 is just 5. So it's the same thing as doing 3/2 times a cube root of 5, or 3 cube root of 5 all over 2. Normally, I don't go through all that writing. I'll just simplify right in here. All right, well, 3 goes into 3 once, and 3 goes into 15 5 times. So the cube root of 1 is just 1, so it basically just goes away, and then I just have that cube root of 5 in the numerator. So that's normally how I write it, but that's why you can do it, because it is just one big fraction. So when you go to do 11, right, I say, oh, look, I have cube root, but I have 20 over 32. I can reduce those with each other. So, what goes into both 20 and 32? 4. So this will become the cube root of 5 up top, and on the bottom, 4 goes into 32 8 times.
Did you take?
I'm not done yet because I can well, I'm not allowed to leave a radical in the denominator anyway, but it just so happens that I don't end up with one because I know what the cube root of 8 is. 2. So I really end up with the cube root of 5 over, if this is 2, 2 times 5 is 10. So there's my final answer there. Does that kind of make sense? Okay. Is that all right? Okay. So, by golly, let's just keep right on keeping on, shall we? I'm gonna leave ones like 13 to 16 for Monday. Let's talk about adding and subtracting real quick, and then we'll basically be done. So, if you look at adding and subtracting, starting with like number 17. Whoa, 17. You already know the rules because they're the same for square roots, but just in case you forgot a big old star here, you can only add or subtract like radicals. So if I just remind you real quick, if you had something like 2 root 3 plus 5 root 3, you're like, oh, okay, those both have a root 3 on them, so I actually can add them together. What is 2 root 3 plus 5 root 3? 7th root 3, right? Do you remember this?
Yeah.
The root 3 doesn't change. It's saying I have 2 of these things and 5 of these things, so now I have 7 of these things altogether. So with square roots, as long as you have like radicals, as long as they're both square root of 3, for example, you can add the coefficients together or subtract whatever you're doing. Multiplying, dividing, it doesn't matter, right? Just like with fractions, right? When you add or subtract fractions, you have to have common denominators. When you multiply and divide, who cares? That's why multiplying and dividing is usually easier. Yeah. So here you have to have like radicals still, whether it's a cube root, a fourth root, a fifth root, whatever it is. But as long as you do, then you can just do the operation on the coefficients. So when I look at 17 and I see, oh, look, they both have cube root of 3. So I'm saying I have 2 of these cube root of 3s, and I want to minus 3 of these cube root of 3s. So what would be left? If I had 2 of these things and I minus 3 of these things, I'm left with negative 1 of these things. So it would just be negative cube root of 3. Yeah, so the radical doesn't change. It's just, you're just doing the operation on the coefficients. 2 minus 3 gets me that negative 1. So try 18. Same thing. Whoa, where's 18? There it is. You already have common radicals, so you can just do the operation, and you'll be done. Okay, what's my answer here? Negative 4, fourth root of 2. That's it. Now, you might get to something, let's look at 22. Here, whoa, 22, there we go. Notice I do not have like radicals all the way through. So, if I don't have like radicals, I can't combine them. Sometimes there are hidden like radicals, but we'll talk more about that on Monday. Yeah, but the cube root of 6, I can't simplify that. So,
Yeah, but don't they just cancel
Yeah, so these two in this case, I can combine the two cube root of 6s. So those two of these minus 2 of these, they just go away. So I am just left with, in this case, 3 cube root of 3. And then let's just do, let's do 1 like 21. So at first glance on 21, this one's kind of a hidden one, but it's not too bad. Oh, that is funny. I don't know why they're doing that, but that's okay. So these, you notice right away, 5th root of 4, 5th root of 4, these have like radicals. So yes, I can combine them with each other. Oh, but wait. This does not appear to be the same as these, because it's the 5th root of negative 4. However, you can simplify that.
That should just be negative I root 4.
You're close. So, all right, that negative right there, I know that it's there, but I'm going to ignore it for 1 second. Let's just look at the 5th root of negative 4. 4's not a perfect 5th, but guess who is? Negative 1. So watch what I can do. I can take the 5th root of negative 1 times the 5th root of 4. Why would I do that? Because now, what is the 5th root of negative 1?
Or I squared.
You're technically right that it's I squared, but what's I squared really? Isn't it just negative 1? Isn't negative 1 times itself 5 times just negative 1?
Yes.
Remember, you can take odd roots of negative numbers, and you don't have to deal with I. Right? Because if I take a negative number and I cube it, it comes out negative. If I raise it to the 5th, it comes out negative.
So it'd be positive 1?
No.
No, like the.
Yes, yes. So this chunk right here, that comes out to be a negative 1 times the 5th root of 4. Okay? But when we go to put it back in this particular problem, right, that replaces this, and there's that negative out in front. So now I want negative 5th root of 4. It actually turns this into a positive 5th root of 4. And then I had plus 3 5th roots of 4 minus 3 5th roots of 4. So my final answer is just yes, 5th root of 4. So sometimes you do have common radicals, but you might have to simplify a little bit to get them first. Okay? So I'm done talking. And you have about, I don't know, what does this end at, 10:08? So we've got it good, almost 15 minutes. And all I want you to do for homework, you're going to finish it before 10:08.
Alright.
I would like you to finish the front. There's only like 6 problems we haven't done on the front. And then on the back, just 19, 20, 23, and 24. That's it. Sure. So just these 4 on the back and then finish the front.